Hello everyone, this is Karamo. So this video we're going to use k-means clustering to group patients based on their cardiovascular risk factors like age, systolic blood pressure, the body mass index, and low density lipoprotein cholesterol. Now, clustering is really important, especially in healthcare, because it can help us to find patterns in the data that could assist doctors in identifying high-risk patients and making better health decisions. So what I'm going to do in this video is to walk you through the process step by step from finding the right number of clusters to interpreting the results. So let's get started. First, we're going to load our dataset we're going to work with in this video. Alright, so dataset is now loaded. Let's see how many rows and columns we have in our data. We got 3,106 rows and 4 columns. Let's see sample of how this data looks like. It's the same data that I just showed you in the previous slide. So we want to see the first 5 rows in this data. So this is how our data set looks like. So we can see that it has different range. The SBP and the LDL have higher values, and this is the age. So the age of the patients are a little bit older. So next thing we are going to do is that we are going to scale our data to standardize to have the mean of 0 and the standard deviation of 1. So we're going to scale the data. So in scaling, we have a new data frame called data frame underscore scale, and file is our data frame name. So now the data is already been scaled. Let's see how the scaled data looks like. So we also have head. We want to see the first 10 or 6 rows of our scaled data frame. So we have our scaled data, and how many rows you want to see? 5. You type 5. All right, so this is our data. It's already been scaled. So scaling here to standardize our data frame or normalize our data to have a fair weight distribution across different variables range. All right, so the next thing we're going to do is to determine the optimal number of clusters. So we're going to determine the optimal number of clusters we have. So in that, we will have FVs. I'm going to explain to you the code later. We have the FVs NB cluster. We need factor external package. This package, let's load this first, and we will also need cluster package. If you don't load these packages, we will not be able to use these functions because these functions are from this package. So we load these packages first. So NB cluster, and in NB cluster we will have our scaled data frame, the data frame that we just scaled. And we want to specify that we will using k-means clustering method. As I said earlier, that we have different types of clustering, but we're going to use k-means clustering. And the method we will use is WSS, within sum of square. WSS. So we're going to add title to our plot. So GG title. Yes. The title we're going to add, let's say, is elbow method for optimal clusters. That's a bit cool. Method for clusters. Very good. So let's run this code and see what happens. I'm gonna walk you through the code one by one to understand what is happening in each line of code, so don't worry too much. So this is our plot we got. We come into this plot later, so let's first explain the code here. So we have these functions, so we have these libraries because we're gonna use these functions from them. So we need to load these libraries first before we'll be able to have access to these functions. So the FVs NB cluster, what happened here, this function is from this package, and it helps to determine the optimal number of clusters for k-means. So the df scale here is the data frame that we just normalized, and k-means specify that we're using the k-means clustering type. And the method WSS uses the within cluster sum of squares approach. And the GG title helped add title to the graph for better readability, that we can able to read the title of our graph. All right, let's minimize this a little bit to fit this the graph to the screen. So in the graph, you have to interpret this. This is called the elbow method for clusters. So the elbow method is used to find the optimal number of clusters, which is the K we have here. So on the y-axis, that represents the total within cluster sum of squares, or the WSS. And on the x-axis, we have the number of clusters K. So overall, this plot shows a sharp decline in WSS initially as the number of clusters increases. When the clusters increases, it shows a sharp decline at the initial point at 1. But then suddenly, at some point, it starts to flatten out. All right. So in that case, we're going to choose the elbow here. So elbow, we have to choose one cluster point, which is our K, because that's where we're going to group our patients into bricks groups. All right, could be 3, could be 4, could be 5, or could be 6. But how do we choose K? Now, looking at the graph, the elbow occurs around K of 3 or 4. Now, let's look at 3 or 4 here. Because if you look at 1, it's sharpening down, it decreases down. And then suddenly, it does not turn elbow yet, because we could see that from 3 to 4, from 4 to 5 to 6 to 10, the distance here, there is no diminishing returns. So it even indicated that even if we kind of plot the graph, the curve starts to flatten out. And this is called elbow point, because adding more clusters at this point does not significantly reduce the WSS, meaning that the extra clusters do not add much value. So the elbow point here is 3, because from this point 1 to 2, after 3, it starts to bend. So when it bends at 3, then it flattens out. So then that means our K here is going to be 3. But why is this important to choose the optimal number of clusters? Because selecting the correct number of clusters ensures meaningful subgrouping. If we select too few clusters, this may lead to under-segmentation. That means missing critical distinctions between patient groups. We're going to miss those parts, right? And if we have too many clusters still, it may lead to overfitting, which making interpretation of our results very difficult for us. So usual in healthcare, optimal clustering helps identify patients' risk groups for personalized treatment. And the next thing we're going to do is to determine the k-means clustering, or to apply the, we already determined the K, so we're going to apply the k-means clustering. So in that, we have, zoom this a little bit, apply the K, apply the k-means clustering. Okay, so we're gonna set dot seed to 1, 2, 3, and then k means results. So okay, k means result is k means, and in k means we're gonna use this second one, the data frame that we just scaled, the scaled data, and we have centers. The centers is 3 because we chooses 3 number of clusters here. That's about these centers. And the next one we have is 25. The n start is equals to 25. 25. All right, so that ends the code. Let's run this code first and see what happens. Let's set the seed first and run this code. So we can also view the k-means results here. Very good. Now, this is the results we got after we run the k-means here. So I'm going to explain the code first, and after that, we will go to the results we have here. So now, looking at the code, set.seed, we set the seed to 1, 2, 3. This could be any random numbers you want to use. And this ensures that the results remain the same each time the code is being run. And the data frame scale, the k-means here is the k-means clustering. So the DF scale here is the data frame that we just normalized, we scaled previously. And the centers here, I got a 3, specifies that we want 3 clusters. And the n start 25 runs the algorithm 25 times with different starting points and picks the best results. Now, when we open these k results here, this is an object we created to run this line of code. Now, when we open these, this is the result that contained in it. And in these results here, it shows that we have many patients that belong to each of the three clusters. So these are first cluster, second cluster, and third cluster. So this is 1, 2, and 3. So that's why we have different clustering vectors here. So these three here, like patient number 1 is 3, belongs to this cluster here. Patient number 2 also belongs to this cluster here, and patient number 1 belongs to this cluster here. Now, what is happening here is in cluster 1, we have 791 patients. Cluster 2, we have 1,181 patients. And cluster 3, 1,134 patients. And in this cluster means here, each row represents a cluster. And the value shows the average or the mean standardized values for each feature we have. Now, when we interpret this table here, for example, in cluster 1, we have here, this could be high-risk patients because the patients are older. If we have a positive number here, that means the value is more than average. If we have a negative number here, that means the value is below average. So in cluster 1, the patients are older, they have high BMI, and they also have high blood cholesterol. So they have high blood pressure because all these are positive numbers. So the minus 0.11 here means that they have low density lipoprotein. And the second groups are healthy group because we have minus here. Then that means all these values we have in each of these variables is below the average. And cluster 3, they have moderate risk groups. The patients are older because this is positive, and they have the normal blood pressure. The blood pressure is not above because it's -2, and the BMI or the body mass index is also lower, but they have the higher density lipoprotein, that is the cholesterol level. So they could be at a little bit risk of cardiovascular diseases. So that's why they are moderate risk. And these are the healthy group, and these group are the higher risk. Now, what we're going to do now is I'm going to create a cluster on the original data. So I'm going to add clusters to the original data here. So original data. So what happened here is that we have our data file, and sorry, it should be $sign data, and all right, file, and we're going to add another new variable. We call it cluster. So in this cluster, we're going to transform it as a factor, and then we have k-means underscore results and cluster. So the cluster should be lowercase 1. Because this is the uppercase cluster. It's a new variable we're creating. So this has already been created. So we use this one. And let's run this code. Alright, so the card is not set. Everything is fine. So let me explain to you what is happening in this code here. So this cluster here, it adds a new column to our original data set. So the k-means result clusters, this contains the cluster assignments for each patient. And this as.factor here converts the cluster numbers into categorical variable format or factor, making it easier to analyze and visualize our data at the end of the day. All right, so the next thing we're going to do now is we are going to draw a table here. So we're going to summarize the cluster's characteristics. So we're going to summarize the clusters. So we need a library called tidybars. Tidybars, okay. Oh, sorry. This is not correct. Alright, so this is out. Okay, so the library is loaded. Let's get this out. Alright, so what we're going to do here is we have an object called cluster summary. And in this, we bring in our file, and then we want to group by. We're gonna group by the clusters. This one we're gonna use. All right. And after we group by clusters, then we want to summarize age. We're gonna round age to mean age. And we will round this to 1 decimal places. 1. The 1 here means 1 decimal places. So we go to the next one. Next one is BMI is equals to round. and we also run that to 1dp. The next one is let me just copy this code, it's faster for me. All right, so copy all this bunch and paste it and paste it. So we can check our variable names here. Let me just run this code out here. Names file. All right, so we're gonna use the systolic BP. So we have the systolic BP, paste it here, and then we have paste it here. And next one is the LDL. We copy this, and also the LDL here. All right, so that's all we're going to do. So we don't need this anymore. And we close this. All right, so that's all we're going to do. Let's run this code and see. The code is correct, there is no error. Now let's see our cluster summary, what we have inside here. Very good. So now let me explain to you what is happening in this table here. Now we have, but first let's go to the code. Let me explain to you the code first, then after we go to the table. Now we have file. Let me bring this down here. Now we have the new object we created, and we have a file. This is our data frame file that we loaded. That's this one, the file here. That is the data about the file. Okay, so the clusters here, we have file, and then this is a pipe operator. We can find it from the tidyverse package. And group by, we want to group by clusters. This groups the data set by the cluster column. This is a new column we created, so it's going to group the data set using this column. And after that is summarize. So this summarize function, what happened is that it calculates the mean or the average value of age, BMI, the LDL, and the systolic blood pressure. So in this line of code here, round mean age 1, this ensures that the values are rounded to 1dp or 1 decimal places for better readability. All right, and this one here, we can even set print if you want, print, and we put this in brackets, summary. It's all the same. If you remove print, it will do the same job. So this line of code here prints or displays the summary table that we want. Now let's go to interpret this or look for the insights we have here. Now in cluster 1, now this is the average patient. Like for example, patients, when we go to this group here, we see that in cluster 1 we have 791 patients. Now in cluster 2 we have 1181 patients. Now the summary we have here is that the average patients, the number of patients we have in cluster 1, their average age is 57, their average BMI is 32, LDL is 119, and systolic blood pressure is 145. So that's what is happening. Now when we look at these average values here, we can deduce that in cluster 1 they are kind of older, because if you look at the average patients in our data set, like here, when you look at the mean of file age, now the mean is 53.7. Let me create a new column here. Let me just X this and here. All right, let me run this again, print results again. All right, so patients in cluster 1, they are kind of older, because this is the mean, this is the average age we have in the whole data set. Now patients in this group are kind of older, and within an average age of 57.6, and they have a higher BMI. The BMI in those in cluster 1 is very, very high. 32 is really high. And they have also higher systolic blood pressure. The systolic blood pressure in cluster 1 patients is also really high. Now for cluster 2, the younger patients, they have lower BMI, LDL, and also they have lower blood pressure. And for those in cluster 3, they are also older patients with higher LDL but moderate BMI and also the blood pressure. So with these, we can have 3 insights, and these clusters help doctors to identify patients at high risk. For example, if you want to introduce a treatment protocol, you're going to look at patients that are at high risk. Now then you can treat those ones first, and then you go to those who are a little bit healthy. Like those in cluster 2 are a little healthy. So if you want to do a treatment intervention or something to control the risk of cardiovascular diseases, you're going to consider probably those in cluster 1 and those in cluster 2. And those in cluster 3 could be the last options to go in for them because they are a little bit healthier based on the average values we have in each of these variables. So clustering is really important because through k-means clustering, we can successfully identify distinct patient subgroups based on their cardiovascular risk factors like age, BMI, LDL, and also LDL, cholesterol, and blood pressure. So this clustering helped reveal some hidden information we can have in the patient's data, which can allow us for better risk assessment strategies. And also, when we understand these, when we understand which of the patients are having high risk, then this can help the healthcare providers to develop targeted interventions and preventive care measures. And also, they can also give lifestyle recommendations to improve patients' outcome at the end of the day. So this is all I want to share with you today in this video. I hope you learned something from this video, and thank you so much for your time. See you next time.